picture here looks a lot like the ones we were already looking at. Particularly, it looks like the ones where we had like the average of the angles, but no angles are marked in this picture. So for this rule, what is always going to be true is that A times B has to equal C times D. Okay? So A and B are the pieces of the blue cord here, and C and D are the pieces of the red cord. So if we're setting that up here for the example problem that we're given, I can look at one of these cords here, and I'm going to multiply the pieces of that cord together. So it would be 24x. And then that is going to equal the pieces of the other cord multiplied together. So in this case, that's going to be 27 times 16. There. You can use Desmos if you want, or you can just use the calculator. 27 times 16 is going to give you 432, so we're looking at 24x equals 432, and then you would just need to divide by 24. And so x would equal 18 for that. Okay, so just the pieces of the cord. You just have to make sure you're using the pieces of the same line. Sometimes kids will do like 27 times 24. That is not correct. Those come from different lines, right? For that. Make sense? Okay? All right, so these next three things that we're going to look at, is it three? No, two. These next two things that we're going to look at could really be used sort of with the same rule. Here, but the rule looks pretty complicated, right? We've got here a secant and a tangent intersecting outside of a circle. So the rule is that whatever A is going to be squared, and that is going to equal B times B plus C. Okay? Now, the way I like to think of this B times B plus C here is the B is the outside part of the line, right? It's this piece right here, the part that's outside of the circle. And then B plus C is the whole line, right? Because if I take B and I add C to it, it gives me the whole line. In a way, A squared is also the outside times the whole line. It's just they're the same, right? The outside is A. The whole line is also A because the whole thing is outside, right? Here, so to set this up, if we look at this picture, our tangent piece, our A piece, is this part right here. And so we're going to do the outside part, which is 12, times the whole thing, which is 12. And that would just give me 12 squared. And then this part here, we're looking at this part here. We're going to do the outside, which is 9, times the whole thing, which is 9 plus x. It's not 9 times x like it was on the last problem. The last problem is going to make a much more simple equation. Now, I am going to solve this by hand because it's not that hard to solve by hand, but let me just remind you about solving this with Desmos. So, because some of you panic whenever the equations get a little bit bigger, but we can solve this with Desmos. Maybe Desmos will come up here. Well, we might not be able to solve it with Desmos. Is it all of the internet or is it just Desmos? Oh, here it comes. Unhappy about doing this. Okay, f of x equals 12 squared. G of x equals 9 times 9 plus x. 12 squared is 144, so I'm going to have to zoom way out on this. And right here, it's going to cross right there at 7. Right. This is also not a super difficult one to solve by hand. I would just need to say 12 squared is 144. I could distribute my 9. I've got 81 plus 9x. I would subtract 81, which is going to give me 63. So let's go over here. I got 63 equals 9x. And then I'm just going to divide by 9. And 63 divided by 9 is 7. But use Desmos if you want, if you'd rather not solve it by hand. Now, sometimes these can turn into quadratic equations. That probably definitely is going to be a case where most of us are going to be better off just graphing it in Desmos and finding the correct answer there. Okay, questions? All right, so if we have two secants intersecting outside of a circle, then what we're looking at here is going to be A times A plus B. So it's going to be over here for this line. A is the outside part. A plus B is the whole line. And that is going to equal for the red line, the same thing. Outside times the whole. To me, this is a little more helpful than this like A's and B's all shown there, but might be helpful to have both of those there. So if I'm looking at this problem over here, it doesn't matter which line you look at first. I think I'll look at this one on the top here. I'm going to do the outside part, which is 7, and then I've got to multiply that by the whole line, which would be 7 plus 5, those two pieces added together. If you want to go ahead and make that 12, that's fine. Then that would be equal to, we're going to look at the pieces of this blue line here. Okay, the outside part is 6, and then the whole thing would be 6 plus x. So this is, it looks more complicated than it really is. It's pretty basic to solve by hand. 7 plus 5 is 12, so we're looking at 7 times 12 equals, we could distribute by 6. There we'll get 36 plus 6x. 7 times 12 is going to give us 84. Now we would just need to subtract that 36 And 84 minus the 36 is going to give us 48. Equal to 6x. And divide by 6 there, and x is going to equal 8. Okay. Keep in mind you could have typed that into Desmos if you wanted, and just found where they cross. That'll work also. Okay, questions here? All right, let me see what I got next. Okay, so I've got a few examples here that I want you guys to try. So I'm going to pause for a second. And all right. Okay, here is what you should be getting. Okay, 4 is going to be 17. 5 should be 4. 6 is 16. And 7 is 32. Okay, when I was walking around, it was looking like most of you guys were getting that. You were setting them up correctly. It looked good. Okay. The most difficult thing about these problems is making sure you're using the right rules, because they're going to be mixed in also with the angle type problems as well. So hopefully the formula sheet will help some with that. Okay, any questions on this? Anything you're not sure about? Okay, let's move on. We got a few more things that we need to know about segments inside of circles. So the first is congruent chords. If two chords are equidistant from the center, they are congruent to each other. The line perpendicular to the chord bisects the chord. So this has got a lot of stuff going on right here. So if it's telling us a couple things. If two chords are congruent to each other, so that would mean in this case that AB equals CD. Those two chords, the chords are these segments right here. If they are equidistant from the center, they're congruent to each other. So that means if these little red lines right here have the same length, then AB and CD have to be equal to each other. Also, if those the distance from the center to the chord is always going to be perpendicular, and if this little red line right here is perpendicular, it is going to cut the chord into two equal pieces. They're going to bisect the chord. So that would mean like this piece right here is going to equal this piece right here. And this piece right here would equal this piece right here. So if we look at a problem like number 8, I have a chord and a line that's perpendicular to it. So that is going to tell me that if this piece right here is 9.8 and this is a perpendicular line, then this point over here, oh sorry about that, is also 9.8. Now they're not asking me for that segment. They want to know the radius of the circle here. I want to know that radius. What could we do to find that radius? A squared plus B squared equals C squared. We can do that Pythagorean theorem. Which side is my C here? Is it the 4.8, the 9.8, or the X? Which one is the hypotenuse? The X. The X is your hypotenuse. So you're going to do 4.8 squared plus 9.8 squared is going to equal X squared. So 4.8 squared, Joey, make sure you're getting this down. Alright, we get 119.08. Joey, you getting this down? Okay, what do I need to do after that? Hunter, what would be the last step to get the answer here? What? Not divide. How do I get rid of a square? Square root. I need the square root. So if I square root that number there, I'm getting 10.912 as my X. So if you see those right angles, you probably got some Pythagorean theorem going to show up somewhere. Okay, questions? All right, got a few more things we need to know. A tangent. A line tangent is perpendicular to the radius drawn from the center to the point of tangency. So if you have a tangent line, and we should remember from our vocabulary, a tangent line is going to touch the circle at just one point. All right? So this tangent line here is going to be perpendicular to the radius here at that point of tangency. So if you see a radius and a tangent line intersecting, then those are perpendicular even if it's not marked. because it's a rule that they are always perpendicular. Okay, another rule that we're going to have here for tangents. Two line segments that share an endpoint and are tangent to the same circle must be congruent. So if I have a line that's tangent here at D and also tangent to that same circle at B, and they intersect over here, then that tells me that line segment CD is equal to line segment CB. Those have to be equal to each other. Okay, questions? All right, so let's look through some of these. Here, I have a line right here. What would I call that line right there? What name would it have? Is it a tangent, secant, chord, diameter, radius? What is it? Not a chord. It is a tangent. One of the things you'll have to do on the quiz is like it'll just like give you a picture and you'll have to name different segments. So we want to be able to do that. This is a tangent. Okay? And it is like it's asking us here for this piece right there. That's what we want to know. Now that is a radius. And we just learned a tangent and a radius have to be perpendicular at their point of tangency, correct? Okay, good. So I'm going to treat this just like this is a right triangle, okay? So this whole thing is 14. That's my C, right? I'm going to have 8.4 squared plus x squared equals 14 squared, and I could subtract 8.4 squared from both sides. So x squared, I'm going to do 14 squared minus 8.4 squared, and I'm going to get 125.44. And once I get to this point, Joey, what do I have to do to finish solving that? Okay, we got x squared equals 125.44. I'm trying to solve for that x. How do I get rid of a square, Joey? Square root. I'll square root both sides. And so x will equal, we'll take the square root of 125.44, and it's going to be 11.2. Is that my answer? It's not, because that would 11.2 would be this whole side of the triangle, right? That's 11.2. What was the question asking us for? For half of that. And so if I divide that by 2, my question mark that they're wanting me to find right here is 5.6. That's going to be my answer for that one. Okay, what do you guys think for number 10? Okay, you are correct. This will be 2.1. What should I do with my 2x minus 3? What type of line would we call this piece here? It will, because these are both, what do we call these right here? They are congruent. Like each one of these lines individually, what type of line are they? towards their tangents, right? Right, those are tangents. They only touch the circle at one point. And so if they are tangents coming from the same point, we just had that property that says they're equal to each other, right? So we can just do x right here. Do we need the 2.1 at all for this? We do not. Now, normally I would try to move this x, but if I do that, I won't have anything left on that side. So I'm going to subtract my 2x. So negative 3 equals negative 1x, and then I'll divide by negative 1. And 3 will equal x. Okay? Try those next two on your own there. Is that if this little piece right here is 9, that is a radius of the circle. So that means this piece right here, which is also a radius, has to be 9. And what we've got happening here is there is a radius and a tangent that meet, so that makes that a right angle. So this side right here, the whole side is 15. That's going to be your hypotenuse. So you're going to say 9 squared plus x squared equals 15 squared. You're going to subtract your 9 squared. That's going to give you 144. And then you'll square root both sides to get that 12. Right there. Okay, questions there? All right, just a little bit more here. All right, for 13, they are giving us this picture where we've got like 4 tangents to this picture, and what are we looking for here? There's nothing marked. I'm trying to remember what the question. Let me look at the worksheet. I forgot to put the directions of what is happening here. Let me see what the worksheet asks you to do on ones like this. Let's see. Oh, it should say find the perimeter of the polygon. All right, and polygon means a closed figure with straight sides, so it's talking about the quadrilateral that we have here on the outside. We need to find that perimeter. So I've got everything except for this side right here, right? I could add 14, 15.5, 10, and 4.3, and I would have everything except for that one side. So the key to this is that if I have a tangent coming from the same point, like from here to here and here to here, what do I know about those two little segments right there? They have to be equal to each other. So this would have to be 4.3. But do I know what this piece is? I don't, because I don't know this piece. I know the whole thing's 14, but I don't know this piece. What I'm going to have to do here is I'm going to have to kind of work backwards, back around. So if I know this is 10, then this is also 10, right? Well, if that whole side is 15.5, what's the length of this piece right here? If this was 10 and this was 10, that whole side would be 20. What would this be? Can't be 10. 5.5, because the whole side is 15.5. This piece is 10, so this would be 5.5, which means this piece is also 5.5. Well, if that piece is 5.5 and the whole side here is 14, then what's the length of this piece? We got to do 14 minus 5.5 That's going to give us 8.5, which means this piece is 8.5. So if we put that whole side together right there, we got 12.8. Right, 8, is that right? 8.5 plus 4.3 would be 12.8, yeah. So now we're looking for perimeter, so we would need to do 12.8 plus this side here is 14. This side here is 15.5. This side here would be 14.3. And so if we add those four together, we got 56.6 as our perimeter. And I want you guys to at least get started on your assignment, so we're not going to do 14. It's a very similar problem there. Okay, questions? All right. Since we are running a little bit short on time here for you to get this started, I'm just going to give you the odd problems on this worksheet. So just the odd problems. You're going to turn it in to the sub tomorrow, so it needs to be done by tomorrow. And I am not going to be able to go over it with you before the quiz. But let me show you this. I'm pretty sure it's here anyway. Let me show you this. On Canvas, under day 3, which is today, you will see, not Canvas, Google Classroom. You will see the worksheet is posted there. It looks like it is the blank worksheet, but if you scroll down enough, the answers are there as well. So you can at least check your work there as you go for that. So the answers are posted so that you can check your work. Also tomorrow, before you start your Delta Math assignment, if you have questions, go find somebody that looks like they know what they're doing, like Hector over there, and he will help you with these problems. Oh, yeah, we do need to do that, don't we? We need to fill in the rest of our, oh gosh. Let's fill in the rest of this. So we got our formula sheet ready to go. This is really gonna, why is it so blurry? There we go. Come on. Focus. Okay, there we go. All right, so the things that we got here today. Oh, was it? It was doing good earlier. Okay. For segments intersecting inside circles, you're going to have A times B equals C times D. And I don't know, maybe it's the